All right, here we go. Success on the IB exam. Now depends on this. Yeah. Okay. Let's take vectors and apply them to a shape. Oh, they love it. They love it. Both two-dimensional and three-dimensional shapes. So a square and a cube, whichever. All right, here we go. Yes. Are you going to be teaching math? Here we go. All right, here we go. Given A, B, C, and D. Well, we don't have B. Sorry about that. What would B be to be a parallelogram? There's a lot of B's. Here we go. Here we go. What's up? Oh, no, I'm good. I'm good. Here we go. Just graphing this puppy. A is at 1, 2. So here's A. True? What's up? Yeah, 1, 2. Just watch. Here we go. Hang on. C is 4 and 1. So there's C. Nope. It's not 4 and 1 is B. Nope. Here we go. No. D is 1, -1. So this is D. All right. Here we go. Hang on. I'll show you. Here we go. So, you're saying 4, -2? Oh. Yeah, no. All right. Here we go. In order for this to be a parallelogram, right? AB, so B is somewhere here. So like AB would have to be parallel to DC, correct? Yay? Okay, so let's set that up. So we know that AB has to be parallel to DC. Yay? Vector AB is B minus A. True? So we can say, bless you, B is X, so X minus 1, comma, Y minus 2. Yay? Whereas DC has to be C minus D, right? Okay. And that would be 4 minus 1, comma, sorry, bless you, I said comma in a caring way, 1 minus -1, like so. True? And if you equate the components, this has to equal this. So x minus 1 has to equal the 4 minus 1 part, aka x minus 1 is 3, so x is 4. Yeah? And this has to equate to this. So y minus 2 is equal to, I'm just going to write 1 plus 1. So y minus 2 is equal to 2, so y is 4? Is that what you said, Brianna? Or did you say 4 something else? Oh. If you went the other way? Yeah. Okay, so one of them.
How do you know which one you're looking for?
Well, I mean, it says find a point. So as long as it's good to go, we're good. Yeah. Mm-hmm. Yeah, because did you go like AC to BD? Is that what you did?
Yeah.
Oh, okay. Okay, so one possibility, this is just one possibility, is that B is 4 and 4. So 4 and 4. There's B, and ta-da, there's a parallelogram. Yay! Yay! It's so good though. Yeah. Okay. Is a parallelogram a square? Is a square a parallelogram? Yeah, it is. Okay, so this brings us to the next case. Have to reach back into geometry. Yay, miss. Who? No? Okay. Here we go. Here we go. Let us just recap all of the different special parallelograms, right? What makes a parallelogram into a rhombus? 4 equal sides. So the only thing for the parallelogram to be a rhombus is that the 4 sides have to be all congruent. Okay? Square is when a rhombus and a rectangle get married and have a baby. Because a rectangle, rhombus is 4 congruent sides, rectangle is 4 congruent angles. So when they get married and have a baby, it's a square. It's the perfect baby. That was my maid of honor speech once at my cousin's wedding. Nope. Yeah. Yes, yeah. She ended up, so my husband ended up getting here like right when the match started. Oh. Yeah. Crunching chips. Oh, and P.S. I learned that boson is not the same as bassoon, so.
Yeah, that was good.
Yeah. I was thinking Little Einsteins. That's what she was watching. Alright. Oh, goodness. You know, Quincy and the Princess Bassoon. You know. Alright. What did I do? Oh my God. Here we go. Wow. All right. So using that figure from the beginning, so this is just the same picture. Yeah, just the same picture as this. Can it be a rhombus, right? So using that same picture, is it a rhombus? In order for it to be a rhombus, all the sides have to be congruent. So therefore, AB has to be the same as DC, has to be the same as AD, which has to be the same as BC. And what I mean by length, I'm talking about magnitude. Yeah, it's magnitude. Yeah. Yeah. All right. So, AB is B minus A. So that would get you 3, 2. Is that right? Is it true? Okay. So this one, the magnitude of AB would be 3 squared plus 2 squared, which is 9 plus 4 is 13, right? So that's AB. Check DC. Yeah, because we have to check for the length of the sides. Are they? Are they? Here we go. DC. So if you subtract DC, so 4 minus 1 is 3, and then 1 minus negative 1 is 2. So yeah, those two are the same because they're parallel. They are. So this would become square root of 9 plus 4 is 13 again, right? But AD would have a different one. So what would AD be? Yeah. 0, negative 3. So this would just be the square root of 9, which is 3. That's not right. And I can stop there, but obviously this should be also 0, negative 3, which is the square root of 9. So because only the opposite sides are the same, that means it's not a rhombus because they're not all the same, right? So not all 4 sides, and since you like symbols, Miss Gabby, are congruent, so this is not a rhombus. Yeah? We decided to need that H in the rhombus word. You know. Very good. Oh, thank you. Thank you. I got you. Let's just write this all down. Hang on. Here we go. Right? Here we go. Okay. Can it be a square square? Well, we just learned that the four sides are not congruent, right? So obviously it's not a square, but just checking on the angles, just check one of the two sides. So for example, if you did A to B to D, how can I check to see that this is 90? Dot product. Yeah. So the dot product of AB and AD is not going to equal 0. Yeah. So not perpendicular, which means it's not 90 degrees. So therefore, not a square. Right? Not a square. So square has to have four congruent sides, four congruent angles. Either of them match. Can it be a rectangle? No, because we just showed that no. Okay. Angles are not 90 degrees. Right? So for a rectangle, if the angles aren't all 90, then it's not a rectangle. You go back? Yay? Okay. Yay! Oh yeah, let's do it. Here we go. Yeah, no, that's okay. Here we go. All right. Yeah, AB is 3, 2, right? And then AD is 0, -3. So 3 times 0 plus 2 times -3 is not 0. True? Got you. Got you. You can also check by doing that cosine formula. Want to do that too? Yeah, no, you totally could. Totally could. Yes. IB likes methods. P.S. Half of the test is method points, so you can literally get half the test if your method's right. Yeah. And to pass, yeah, well, there literally you can get a 40% on the IB exam and pass because that's like a 3. So yeah, yeah. Okay. Here we go. They're not gonna get. Okay, listen. This class, all right. I'm expecting 5, 6s, and 7s. So come on. Here we go. Yeah. I can't even expect that from HL. Yeah. Huh? Yeah. All right. Let's add another dimension to our problem. Right. Yeah, let's do it. Let's do it. Okay. 3D vectors. Ready? When you write a vector in 3D, it goes length times width times the height. Yay? Okay. So for example, our starting point, our position vector is F for flex. Here we go. So this right here, my dears, is our position vector. Okay? So to find all the other vectors, we just base it off the movement from that vector. So for example, to find vector A, we're moving across the length and up the height. The only thing that doesn't change is the width. Yeah, to get from F to A, you have to go over then up, right? So to get to A, you have to add the length and add the height to vector F, which has, sorry about this, I should probably write this down, has the vector, it should be on there, right? 2, 5, -6, right? It's at the bottom. Yeah, there it is. All right, so to get to A, you go over, then up, which means that, no, to get to A, I have to follow, oh, once you do that, you go from here to here, then here to here, and your resulting vector is this, right? Yeah, so that would be the resulting vector to get to A. Yeah? Okay. Yes? No, maybe? Yeah. What's your question? the length and the... You could, but it's so much easier just to add it. Yeah? Let me write it down. Hang on. It'll make sense. Here we go. All right. So to find vector A, right? All we're doing is from 2, we have to add 12 to that, right? We didn't move the width, so that just stays as 5. But from -6, we have to go up 10. Right? It's distance. It's distance. Yeah. Yep. Right? So vector A has the coordinates, or the vector 14, 5, and 4. Like so. Make sense? Okay. No? Let's try it again. Let's try it again. All right. Yellow. Oh, because you follow straight line paths for vectors. So this vector, to get to this vector, you have to go over then up, right? To get to this point, you have to go over then up. The resulting vector that connects A to F is because you went over and up that much.
So can you pretend that dotted line?
Sure, sure. All right.
What if you did?
Ooh.
No.
What are we gonna do?
Like if you just like really close to the extra, you go from like F to H.
Well, I mean, no. So here's F. Well, I mean, shortest distance. Alright, let's find all these puppies. Here we go. So to get to B, right? You just have to add to the H. You just have to add 10 to the H. So for B, the 2 stays the same, the 5 stays the same, but you just go -6 plus 10. So it's 2, 5, and 4 is B. Yep. So that's the vector equation for B. Yeah, let's do it. Okay. To get to C. Yeah. To get to C from F, you have to travel through this width, 8, and then up 10. So the width and the height is what's changing. So the length stays the same. The width is 5 plus 8, right? And then -6 plus 10, which is 2, 13, 4. True? True. Mm-hmm. D has a what? Yeah, because D and C are in the same height field, right? Oh, you are so smart. Here we go. All right, so D. To get to D, you have to add 12 to the length, right? Because you travel across the length. Then for the width, you have to travel across the width, which is 8. And you have to travel across the height, so -6 plus 10. Oops. So 14, 13, and 4. That's a 14. Sorry. Yeah. So sorry. Siri? All right. All right. This one. Yeah. What should you? Oh yeah. So yeah. All right. A B C D. E. Yeah. Okay. To get to E, let me move up. Here we go. That's it. Just add to the length, right? Yeah. That was boring. Here we go. 2 plus 12, but everything else stays the same. So 14, 5, -6, like that. Yay. We have F. We need G. Okay. Okay. Whoa, did you do it already? You're so good. I don't even know it. Okay, here we go. F, E, F. We have it. G. Okay. So what are we adding to? Yeah, length and the width. -6. So 14, 13, -6. Is true? Yeah? Okay. And, yeah. H. All this knowledge is rushing through your head like your blood when you're upside down. Here we go. H. What's changing? The width. Thanks. Yes, keep the color. Jeez. 2. 5 plus 8. -6. I heard distress. Where's the distress? 2, 13, -6. Joy? Whew. Okay. So, that's all and good and all, but what can we do with those vectors? I don't know. Maybe find some magnitudes and some angles? Let's do it. Let's do it. Yeah, let's do it. It's awesome sauce. Yes, love. No. We're doing like every possible thing you do with vectors, but when it comes to tests, it's like it's pick and choose. It's not the entire process. Yeah. Excellent, because you're a genius. There it is. Yeah. Okay. Here we go. 45? No. Yeah. Good try though. Good try. All right. Here we go. So, in space. Here we go. In space, how do you find the angle of something in space? Well, this brings us back to last time. Remember, to find the angle, we need two vectors. So we need vector G, B, and vector G, A. Yeah. Okay? Here we go. Using our vector equations, GB is just B minus G. Hello. Right? So if you subtract G and B, do you take my word for it that it's -12, -8, and 0? Yeah. Sure. Yeah, from the previous. That's why they're next to each other, right? On that page? Okay. Okay. It's 10. It's 10 because, that one was missing. It's 10. Yeah. Yeah. All right. B is 2, 5, and 4. It's 10, right? Yeah. Okay. A minus G. 0, -8, and 10. Right? It's a good time. All right. So, to find the measure of the angle. So, the measure of angle BGA, sure, is equal to the inverse cosine of, ready? Whew! Dot product, so, yeah, -12 times 0 plus -8 times -8 plus 10 times 10 over square root of 144 plus 64 plus 100. Okay, yes. What? Hang on, let's finish this. Here we go. 144 plus 100 is 244 plus 64. 244 plus 64. 308, yep. Yeah? All right. 0 plus 64 plus 100 is 164. All right. The magnitudes. A squared plus B squared plus C squared. Done? 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 Okay. It's true? All right, Samya. Yeah. Amanda, please? Oh. Did you round it? Round it to like a couple dozen places. Okay. So about 43.1. Yeah, 3. So 4. Yeah. Yay! That was so much fun though. Was it? Was it? Okay. Oh, that was just part A. Well, part B says find the length of BG, and we did it. We did it. The length of BG is right here. What's that? 144 plus 64 plus 100 is. What is it?
Oh wait,
Yeah. Yeah. Even if it's reversed though, right? Wouldn't it just be the same? So you're squaring, so it doesn't matter if it's positive or negative. You'll just square all the negatives away. Okay, no, this is the vector. The length is the magnitude. So the magnitude of GB should be the same as BG. True? So this is the square root of. Yeah. All right, Angelo, talk to me. Which one?
How can you educate children about it?
No, good. This is good. Yes, magnitude is. It's a distance. So distance is always positive. It's a square root, so you can't take square root of negative. Yeah. Yes. The magnitude. Since it is single number, yeah, it would technically be called a scalar, but you don't use it as. Actually, no. Sometimes you would use it as a scalar, but that's like. All right. What? Applications? Okay. Okay, almost done. Almost done. Here we go. Oh, there's more. All right. Yes, in France. Here we go. Okay, this is it. I promise. I promise. Okay. Here we go. Applications, right? We've been working with vector equations. You can easily convert a vector equation into a Cartesian. In other words, a squared plus b squared c squared, like ax plus b at y plus c, right? So there's something called a Cartesian equation. Easily done from the vector equation, if you remember what everything means. So here we go. The position vector is the initial position, right? The position vector is always next to the scalar, which is s, right? So this is the position. Nope, wrong. Position. Now I'm lost. Position, direction. Yeah, direction. That's right. That's right. Here we go. The position vector is the initial vector. The direction vector is next to the scalar. The scalar is the magnitude of that vector. Okay? So, for example, I'll write it all out. Got you, got you, got you. Here we go. Yeah. Yeah. That we talked about with R, yeah. Okay. Here we go. In this example, ready? Our starting point, our initial point that's not being changed by any scalars or anything is 6. Yep. So 6 negative 4 would be the position of this vector, right? To find its position at time 2, remember s is the time of the vector. So you're just solving 6 negative 4 plus 2 times 10 8, right? So hello, 6 plus 2 times 10, which would be 26. Negative 4 plus 2 times 8. 12. So the vector would have a position at 26 and 12. Yeah. Cool. Okay. What's the velocity vector? Yeah, the second one. So 10 and then 8. Yay. All right. The speed of the object. Now, the scalar is the magnitude of the vector. The speed of the object would be the magnitude of that vector. Okay. So it would be the magnitude of the direction vector. So this would, no, because velocity takes into account direction as well, right? Yeah. All right. So this is square root of 10 squared plus 8 squared, which is the square root of 164. Yeah, which is about 12.806. So to find this, the speed, just find the magnitude of the direction vector. Yeah. Joy. Yeah. All right. We're gonna get to an IB problem eventually, so make sure you know where this page is. But we're gonna get to an IB problem where you have to find all these little pieces from a vector. Yeah. All right. Here we go. Last pieces. All right. Here we go. To change from vector to Cartesian form. By Cartesian, I mean x's and y's. So this thing right here is called Cartesian form. Cartesian, like Rene Descartes, because it's the Cartesian plane. His name was Rene. Yeah. All right. Here we go, Seth. I love that you think ahead. Here we go. Remember that. A vector has components x, y. True? So in other words, xy is equal to 4, 6 plus m times negative 2, 1. Yeah? This is just like before. The x component is equal to 4 plus negative 2m. True? Right? Which means x minus 4 divided by negative 2 is m. True? Okay. The y component is equal to 6 plus m. So y minus 6 is equal to m. Now what? They're not equal to each other. So, bringing these two together, you have x minus 4 over negative 2 is equal to y minus 6. What's up?
So like we can get rid of one of the variables.
No. What form do we need? We need x's and y's.
Oh yeah.
Right? Right. I'm going to multiply the 2 to the other side. Is that okay? X minus 4 is equal to negative 2y plus 12. Yeah? And remember, it has to be ax plus by plus c equals 0. So to set the other side equal to 0. So x plus 2y, and then minus the 12 would be, is equal to Cartesian form. There it is. Yeah. Would you look at that now? I don't have a negative on the edge. Yeah, I like to keep the x one positive. It doesn't really matter, but it's just cleaner. Yeah, I think so. I think you're right. Yeah. Is that enough, Kylie? Yeah. Okay. You want to try one on your own? Yeah. Next one's yours. Go. Here we go. All right, so here's Gabby's work, right? Let's start from the beginning, make sure she's good to go. First of all, were these two okay? Okay. All right, so what she did was, what happened was, here we go. All right, when you move the 2, you move the 6. Okay, so when you multiply this side by 6, the 2 divides into the 6, and that's a -3. That's true. That's true. Yeah? And then multiply the -3 to both sides, so -3y plus 15, that's good. X minus 3, so the x is positive. Move the 3y over, and then subtract the 15 over. Yeah, now, if you do it cross multiplication, you would get the same thing, you just get bigger numbers. So, starting over, x minus 3 over 6 is equal to y minus 5 over -2. Be -2x plus 5. 6 is equal to 6y minus 30, right? And then setting it equal to 0 is 2x plus 6y minus plus minus 36, right? Yeah. That's the scalar. So there's a scalar of 2. It's just x plus 3y minus 18. So again, these are the same vector because they're just, yeah.
It's called scalar.
It's a scalar. Yeah. Yay? Oh. So yeah, so either this one or this one would be a Cartesian equation. The scalar doesn't affect the equation. Yeah? Okay. All right, here we go. Now, classic IB question. It's probably going to be in your summer assignment. Hint, hint. All right. If I gave you, star, wink, wink, like there's something in my eye, wink. All right, here we go. Yeah. To find the acute angle between 2 lines. Oh my gosh, I've seen this question so many times, and it's scary. Here we go. To find it, you need to be able to go from Cartesian right back to vector again, and then do the cosine thing. Yay? In order to do that, here we go. Do we agree that this thing is y1 is equal to x minus 3? True? Yeah? We need to change it from Cartesian back to vector so that we can do the cosine formula. True? Yeah. Which is, line is Cartesian, but okay. All right. And doing quick math under your head. Oh gosh. Here we go. Yeah. Plus 11 over 2. True? Okay. So, y1 has the vector equation. Let's see if I remember how to do it. 1 over 1 m plus 0, -3. Gabby! Gabby! It's been a while, like from the first day. So this is slope. Slope. Hang on. Slope and then the y-intercept. Yeah? Go ahead, Gabby. Yeah. Uh-huh. Nope. Nope, because I just haven't switched this time, didn't I? No. As long as you know which one's position and which one's vector. But bless you, love. All right. Here we go. This second one, y2, has direction n plus 0, 11 over 2. See, aren't you glad we did this? Oh, man. No, it's even better. It's even better. Got you. All right. Remember that these lines exist from the position vector. So all you need after that is the position, I'm sorry, the direction vector. I'm sorry about that. You just need the direction vector to figure out the angle between the two lines. So you need to know what direction the lines are going to find the angle between. Does that make sense? Yeah. So that means the angle between them, what am I doing? Go away. Delete. Yeah. All right. So the angle between them is just going to be the inverse cosine of everything we've done before. So 1 times 2 plus 1 times negative 3 over the square root of 1 plus 1 is 2 times the square root of 4 plus 9 is 13. Yay? Right? Oh, you only need the direction because the direction tells you like the direction of the rays, so you can figure out the angle between. Yay? Okay. Ooh! Does that answer the question? No, because the question says find the acute. This, my dear, is obtuse.
So would you just subtract
From
180?
180. Girl, you got it! Here we go. To find the acute angle between them is just 180 minus 101.310, which is 78.69 degrees. Yay! Oh my. We're all following Kylie, is that what we're doing? We're all putting your leg on the table and doing that stuff. Alright. Alright, my love. So, the plan is that let me freeze this really quick. For Tuesday, right? For Tuesday, come meet here first. Alright, we'll get any questions you have answered before you take off and go to CAS, and then over Thanksgiving, you get to pray over vectors. Yeah.